Welcome to the 787 Flight Instruments lesson. In this module, we will discuss the heads-up displays. This module will primarily address the differences that exist on the HUD as opposed to the PFD. Refer to the PFD topic in Module 2 or the company manual for more information about display symbology. The airplane is equipped with two heads-up displays, or HUDs, one for each pilot. These displays operate independently from each other. The system projects flight data symbology onto a transparent glass combiner screen in the pilot's forward field of vision. This allows the pilot to see the data while looking through the forward windscreen. The HUD and PFD receive flight data from the same sources. Thus, HUD indications match PFD indications, though data format and symbology may differ. The overhead units are located above the head of each pilot. Each overhead unit contains an LCD projector and the optics necessary to display flight data symbology onto the combiner glass. The HUD projector is monochromatic, so all information displayed on the HUD combiner is green. Glass combiner screens are attached above the forward windscreen on a rotating dual-arm assembly. A locking mechanism is used to secure the combiner in the stowed position. Combiner release is accomplished by sliding the locking lever to the right. Push the combiner assembly down and forward, allowing the assembly to snap into position from spring tension. An Align HUD message is shown left or right of the airplane symbol on the combiner screen if it is not properly aligned with the projector. Ensuring the combiner is positioned at the stop removes the message. Stow the combiner by lifting the combiner up and back until the latch engages in the locked position. The symbology and brightness controls are the only dedicated HUD controls. The HUD system does not have an on-off switch. Deploying the combiner turns on the projector. Manipulation of the FMS, EFIS, and MCP controls determines data output on both the HUD and PFD. Symbology control switches located on the outboard side of each control wheel allow each pilot to alternate between full and decluttered display modes. Brightness controls for each HUD are located on the overhead panel. When the brightness control is pushed in, the display brightness automatically adjusts to maintain a constant display contrast level when background lighting changes. With the brightness control pulled out, the display brightness level must be manually adjusted to maintain a constant display contrast level when background lighting changes. In either situation, rotating the brightness control will set the brightness and display contrast level. The data format and symbology displayed on the HUD closely resemble the symbology on the PFD, though some differences do exist. One of the major differences between the HUD and PFD is that the HUD is capable of displaying two different symbology modes: full and decluttered. The full symbology mode shares many common elements with the PFD. These include speed and altitude tapes, lateral and vertical navigation performance scales, bank angle indicator, and flight mode annunciations. A partial compass rose is also at the bottom of the full symbology HUD display. The decluttered mode eliminates airspeed and altitude tapes, displaying only digital values. The partial compass rose is also removed. Due to the monochromatic limitation of the HUD display, many alerting functions that use color symbology on the PFD may use other indications on the HUD. These indications include flashing, shape filling or blanking, and highlight box symbology. The HUD pitch scale normally displays 5-degree lined increments above and below the horizon reference line. These lines should conform to the outside world. For example, as the pilot looks through the HUD, the horizon reference line on the HUD pitch scale should rest at or near the actual horizon outside the airplane. At higher altitudes, the HUD horizon reference line may appear slightly above the actual horizon due to curvature of the Earth. If the HUD horizon reference line or the flight path vector symbol cannot be shown on the display due to excessive pitch up or down, the pitch scale compresses to make room for these symbols. The pitch scale then displays 10-degree increments. At excessively high or low pitch angles, chevrons are displayed, directing the pilot to pitch the airplane back toward the horizon. For example, if the airplane pitch angle is excessively high, a downward pointing chevron is displayed on the positive 30-degree pitch scale line to direct the pilot to pitch down. If the airplane pitch angle is excessively low, an upward pointing chevron is displayed on the negative 20-degree pitch scale line to direct the pilot to pitch up. The unusual attitude symbology is displayed when pitch is less than negative 20 degrees, pitch is greater than positive 35 degrees, or roll exceeds 55 degrees in either direction. In an unusual attitude situation, only symbology necessary to help recover from the situation is displayed. The unusual attitude symbology replaces the full or decluttered symbology. Any pitch scale compression with chevron is also replaced by the unusual attitude symbology. The unusual attitude symbology includes a zenith symbol centered on the positive 90-degree pitch scale line, a nadir symbol centered on the negative 90-degree pitch scale line. The UA symbology remains displayed until the airplane pitch angle is between negative 5 degrees and positive 10 degrees for 5 seconds, and roll angle is less than 10 degrees for 5 seconds. Once the recovery maneuver is within these limits, the UA symbology is replaced by the full symbology mode, regardless of the mode the HUD was in before encountering the unusual attitude. A numerical digital heading value displays the current heading below the roll scale slip-skid indicator. This value corresponds to the heading on the horizon reference line of the pitch scale. Takeoff guidance becomes available when HUD takeoff guidance has been selected on the FMC. During a HUD takeoff, ground deviation indications include ground roll reference symbol, flight director guidance cue, and ILS localizer deviation pointer. These indications become active when the heading of the airplane is within 45 degrees of the runway heading, and the plane is within 2 degrees of the center of the ILS localizer beam. If the airplane then deviates more than 23 feet right or left from the runway centerline, a flashing triangle appears, pointing in the direction of the runway centerline. In toga mode, flight director vertical guidance is depicted as a horizontal dashed line across the HUD pitch scale. To comply with this guidance, place the airplane reference symbol on the toga reference line. During takeoff roll, the toga reference line is displayed when flight director toga mode is active and ground speed is greater than 65 knots. The toga reference line is displayed in flight anytime the toga mode is selected. When the TOGA reference line is positioned above the airplane reference symbol, a Flight Director Pitch Up command will be displayed. When the TOGA reference line is positioned below the airplane reference symbol, a Flight Director Pitch Down command will be displayed. The flight path vector symbol provides an indication of where the airplane is headed. The flight path angle is indicated by the position of the center of the flight path circle relative to the pitch scale. The flight path vector symbol's gull wing wing roots are angled downward 30 degrees to the horizontal. Therefore, in a 30-degree bank angle, the upward wing's wing root is parallel with the HUD horizon and pitch scale lines. The flight path vector symbol is only displayed in flight and has display priority over all other symbols except the guidance cue. If any portion of another symbol, excluding guidance cue, is positioned inside the circle of the flight path vector symbol, that portion of the other symbol is not displayed. The flight path vector symbol appearance can be limited laterally by other symbology, such as speed and altitude tapes or the display field of view. When this occurs, the flight path vector symbol has a dashed outline instead of a solid outline. The guidance cue is associated with the flight path vector symbol. This cue represents flight director guidance and is displayed when the flight directors are turned on. To follow flight director guidance, position the circular body of the flight path vector symbol around the guidance cue. The guidance cue will appear at 50 feet radio altitude on takeoff. If a HUD takeoff is selected, the guidance cue appears at the same time as the flight path vector. During a traffic conflict, TCAS will display a corrective advisory on the HUD. The corrective advisory indicated with a double-lined box is called the Fly To box. The Fly To box is an indication of where the flight path vector symbol should be positioned in order to obtain vertical separation from traffic. The airplane's AOA limit is depicted on the HUD by the angle of attack limit symbol. The distance between the AOA limit symbol and the flight path vector symbol represents the margin available before stick shaker occurs. When the AOA limit symbol is positioned on the flight path vector symbol, the airplane is at the stick shaker angle of attack. The PFD contains a similar symbol called the pitch limit indicator, or PLI. However, on the PFD, the PLI is displayed relative to the airplane reference symbol, not to the flight path vector. The AOA limit symbol is displayed when the angle of attack is within 5 degrees of stick shaker, the stick shaker is active, or the wind shear alerting with guidance cue is displayed. The HUD slip-skid symbology consists of two symbols. A roll scale slip-skid indicator is referenced to and rotated with the roll scale pointer, and a flight path slip-skid indicator referenced to the flight path vector symbol. The flight path slip-skid indicator is only displayed during a takeoff or a low-altitude go-around, providing additional yaw reference in the case of an engine failure. At low altitude, the sensitivity of the slip-skid indicators is enhanced to provide additional awareness. The speed error tape shows the difference between the indicated airspeed and the selected airspeed on the mode control panel. However, this speed error tape is not displayed until first flap retraction. The speed error tape is positioned on the left wing of the flight path vector symbol. If the indicated airspeed is faster than the selected speed, the speed error tape rises above the wing. If the indicated airspeed is slower than the selected speed, the speed error tape falls below the wing. Each degree of speed error tape length, which is approximately the diameter of the flight path vector symbol circle, represents approximately 5 knots of airspeed error. The tape length is limited to a 15-knot error indication. The inertial acceleration or deceleration of the airplane along the flight path is indicated by the flight path acceleration symbol. This symbol is an indication of the total sum of all forces affecting the airplane. In flight, the flight path acceleration symbol is positioned to the left of the flight path vector symbol. When the flight path acceleration symbol is above the wing of the flight path vector symbol, the airplane is accelerating. When it is below the flight path vector symbol wing, the airplane is decelerating. To maintain a steady state, the flight path acceleration symbol should be positioned directly to the left of the left flight path vector symbol wing. To avoid confusion in controlling airplane thrust, the flight path acceleration symbol is removed from the display when a low-level decreasing performance wind shear is detected below 400 feet AGL. During approach, a horizontal dashed line is displayed across the HUD pitch scale to depict the projected glide slope angle of the active approach. The glide slope angle numerical value is digitally displayed adjacent to the glide slope reference line. During visual approaches, a precise descent angle to the runway is maintained by overlaying the glide slope reference line on the runway touchdown zone, then maintaining the flight path vector symbol on the glide slope reference line. Runway edge lines are a projection of an 8,000-foot long, 200-foot wide runway. The runway edge lines symbol is composed of the runway edge lines displaying the calculated position of the runway. The system also displays 2 tick marks that correspond to the touchdown aiming point. The runway edge lines display in the decluttered mode only. They are enabled at a radio altimeter altitude of 300 feet and are removed at 60 feet. A ground deceleration rate scale is shown on the HUD during landing or when a deceleration is sensed on takeoff. A vertical indexed scale and pointer indicate the actual deceleration rate being achieved. During takeoff, the scale is not displayed, but is added to the display if a deceleration is sensed when the ground speed is above 50 knots and the airplane is still on the ground. Once displayed, the scale is removed when ground speed decreases below 25 knots, the airplane begins accelerating, or the airplane lifts off.